Okay, then let's go to the last speaker in this session, Professor Fang Luo. Professor Luo is a psychologist from Beijing Normal University, and her research field is psychometrics. Using multimedia technology, Professor Luo and her team have developed interactive tests of creativity, critical thinking, and complex problem solving to evaluate higher order thinking ability. Professor Luo will share her experience in developing a game-based assessment to measure creativity of humans. Okay, welcome, Professor Luo. We can see your slide. Okay.
Okay, thank you for sitting. And hello, everyone. My talk is development of a game-based assessment to measure creativity. It's an example of how to develop a psychological test. We don't use AI technique or data-driven method, but I hope it can shed a bit light to interpretability. At present, assessment under under virtual thematic situation brings new vision and challenges to the field of psychometrics. Compared with the traditional paper and pencil assessment, the game-based assessment can construct a test situation close to the real life. Game-based assessment has 5 core elements: interactive problem solving, game rules, adaptive challenges, real-time feedback, rich sensory stimulation. Game assessment provides the possibility to establish ecological assessment of higher order cognitive abilities. As we all know, in the 21st core skills, creativity is difficulty to be measured. The concept of creativity itself is complex and contains multidimensional components. The standard definition of creativity includes 2 dimensions: novelty and usefulness. Creative ideas should not only be novel, but also fit the problem situation. The definition and the theory of creativity are very diverse. Creative problem solving combines the creative thinking process and the problem solving process. CPS refers to the process of finding creative solutions to problems in a novel, flexible, and original ways. Since CPS was proposed, researchers have proposed a series of CPS theoretical models, among which the idea generation is the core stage of the creative thinking process. Due to the diversity of creativity constructs, there are many kinds of creativity measurement tools, including divergent thinking test, creative personality inventory, creative achievement inventory, and so on. According to Torrance and Goff, there are no less than 255 creativity tests, among which the most widely used creative cognitive tests include divergent thinking test and insight test. The divergent thinking test emphasizes the central role of divergent thinking in creative activities. Divergent thinking test refers to the ability generate a large number of ideas from different angles and in different ways. The opposite of divergent thinking is convergent thinking, which refers to logic and reasoning ability, and often leads to a unique solution. Inside problem that test mainly tests and the ability of individuals to look at the problem from a new perspective and get the answer when facing the deadlock, such as breaking the functional fixation. Divergent thinking test and insight test are both popular creative tests, but both tests have a lot of limitations. This study intends to develop a game-based creativity test to address the following questions. Consider usefulness in creative game task design and evaluation by creating real game question situation and setting up highly creative answer sets in advance. The answer space of the subjects was constructed. Creative problem-solving skills were examined in the creativity measurement, and ill-defined problems were constructed in the game. The problems included a variety of creative solutions, and the individuals were guided to experience the cognitive process of creative problem solving. Divergent thinking, convergent thinking, and insights were also examined. We plan to develop a creativity test in the form of game and human-computer interaction to improve the ecological validity of creativity measurement. Process data of the participants were collected to form log files, and a process index system of creativity was established. This study used the evidence-centered test design framework. The task design of the game refers to the creative problem-solving ability model, which involves 4 stages: problem exploration and identification, opinion search, solution search, and solution evaluation. Each sub-process involves both divergent and convergent thinking. Then, I'm going to describe the game task design. We created a problem situation of primitive life with 3 game levels: hunting, crossing a river, picking bananas. The goal of the game mission is to find as many creative solutions as possible in a limited amount of time by combining cards. Get clues in the preset animations triggered by combining cards. The problem-solving process can be operationalized as a sequence of actions combining different cards. Three outcomes can be triggered by different card combinations. Make a combination card. Since some cards are combined to form new things. Animated feedback. The objects on the card feedback clues through the animated content. Able to combine. Illogical cards cannot be combined. The above 4 pictures show 4 ways of picking bananas. The design of creative solutions in this study is divided into the following two stages. Use brainstorming to generate a collection of potential creative solutions. Through the collection of data, the creative solution set was further screened according to the frequency of solution responses. The evidence model is described below. The log file records the card combination status of each step by a participant, so as to obtain his creative scheme of each time. This study identified 5 measurement indicators: total number of paths, total number of steps, total number of creative ideas, total number of clues, total number of ideas beyond the preset. Study 515 students from a university in Shanxi province of China were selected as subjects. Divergent thinking test, insights test, intelligence test, and the creative personality inventory were used as external criteria. This study is divided into 2 sub-studies. Study 1 examines the psychometric properties of the creative game test. Study 2, Bayesian network methods, was used to explore the relationship between answering process and the insight ability, further providing the evidence of test validity. The bars show the average number of solutions found and the scoring rate for each of the 3 levels. The results show that the difficulty of the test is high. The second level is more difficult than the first. Analyze the difficulty and the discrimination of the answers. First, the frequency of creativity in level first ranges from 0.05 to 0.97. Second, except the 10th scheme, which has a low discrimination. Other schemes have a not bad discrimination. The second level, Chris a River, showed similar results to the first level. The difficulty of the third level is higher than that of the first 2 levels. The criterion correlation of divergent thinking test showed that the total number of creative ideas was the most correlated with the flexibility index of graph test, reaching 0.29. Considering the large difference between the game test and the divergent thinking test, a correlation of 0.29 is a good result. The criterion correlation of insight problems showed that the total scores of paths had the highest correlation with the insight score, and the correlation coefficient was 0.3. This is a significant correlation between the total score of paths and Raven's test, indicating that the game test involves some convergent thinking, such as the reasoning ability. In study 1, we examined the measurement properties of the game test and found that the insight score was most correlated with the past total score by multiple regression. Therefore, in study 2, we sought to test the role of insight in the creative problem-solving process in games. At the same time, we investigated whether the answer steps designed in this study could reflect individual difference in the insight ability. We constructed a discrete Bayesian network according to the relationship between preset creative path steps and the insight ability. We divided the subjects into low, medium, and high insight ability groups. Comparing the Bayesian networks of the first and the third level, it can be seen that the difficulty of creative scheme synthesis increases. The results show that the most participants found the first step of creative solutions, and the probability of combining cars was high. The difference of the probability reflects the routine of the scheme. The probability of people holding tools is higher than that of the combination of animals and neutral environment, or the combination of only animals. From the perspective of 16 key steps in the first level, the conditional probability of 7 combined cars meets the research expectation. The high insight group had the highest synthesis probability, followed by the medium group, and finally the low groups. This indicates that there are differences in the completion degree of steps in different insight level groups, and the insight level affects the final completion degree of a scheme. See an example in the first level hunting. The method of hunting is to fish with bugs in the cabbage and vines. Worms are rotated from cabbage and combined with vines to form a simple fishing pole. This path is divided into 4 steps. Except for the first step, individuals with different insight levels have different probability of completing the plan. For example, when given a bug, the high insight person were more likely to think of the fishing pole combination. The perspective of the cognitive mechanism of insight. To find the solutions, it's necessary to represent the task objectives and problems, and overcome the influence of the thinking set. In addition, we meant that the rich game process data from 2 perspectives. Firstly, the problem-solving process of students in this game was regarded as the learning process of creative skills, and the knowledge tracing was used to model and discover. First, students could easily master the card combination method and found the first step of the solution. However, it was more difficult to acquire the skills to complete the creative scheme. This is in line with the real creative thinking activity. Usually, People are easy to get the initial inspiration, but how to refine and perfect a complete creative solution is a difficult ability to master. Secondly, we introduced the complex network technique to show the participants' game behavior and constructed an undirected weighted network with cars as nodes and combination cars as adjacent edge. Network density, distance, centrality, clustering coefficient, and other important statistic indicators were used to describe the characteristics of creative thinking network. That's all. Thank you for your listening.
Thanks, Professor Lu, for your wonderful talk. It is very interesting to see how we assess creativity from the expert's view, and this is actually a very explainable process and have many insights. And it is very interesting to see whether human machine learning models can be used to replace this process in an explainable way. Thank you, Professor Lu.